Hello dear friends, good morning to all of you. Today we will see the examples of chapter number 6, that is electromagnetic induction exercise. Now in exercise we will start with calculation of example number 3. Now in example number 3 we are given that a long solenoid with 15 turns per centimeter has a small loop of area 2 centimeters square placed inside normal to the axis of the solenoid. If the current carried by the solenoid changes steadily from 2 ampere to 4 ampere in 0.1 second, then what is the induced voltage in the loop while the current is changing? Now for the given question, we are asked to find out the EMF. We are provided a particular quantities, a particular values of the question, that we are given a long solenoid, then we are given the number of turns for the solenoid. So, number of turns for the solenoids are given, that is 15 turns per centimeter, so it will be a 1500 turns per meter. Area is given as a 2 centimeter square, so it turns out to be 2 into 10 raised to minus 4 meter square. Now they have also given that the current steadily changes from 2 ampere to 4 ampere in 0.1 second time period. So almost all the conditions that we are provided here, we use the equation, that is E is equals to d phi upon dt. So we will follow this formula, as we know that phi is given by the equation b into a. So when we replace that equation over here, we get delta of b into a upon delta t. Here cross section area A remains constant, so we are not going to change the cross section area, and all other terms that we are provided, that are kept in this equation, as we have the basic equation of that solenoid's magnetic field, that is B is equals to mu 0 Ni, that we have kept over here. So now when we put all the values, we ultimately get mu 0 N A into I2 upon I1 upon delta t. So when we put all these values, we have the answer, that is 7.5 into 10 raised to minus 6 volt. So this would be one of the easiest question that we have obtained. In a similar manner, we are given example number 5. 5 has the term that a 1 meter long metallic rod is rotated with an angular frequency of 400 radian per second. So as we go with the example, we are given that suppose a rod is given, this is the axle, the length is 1 meter as it is given in the information, and it is rotated in this manner. We consider that it is rotated about its axis. Now from the equation we are given that it has a frequency of 400 radian per second. So here they have given us the frequency that is 400 radian per second. So we can put it here, that is length is 1 meter, frequency is 400 radian per second. Then about an axis normal to the rod passing through its one end, and the other end of the rod is in contact with a circular metallic ring. A constant and uniform field of 0.5 Tesla. So we are also provided the magnetic field, that is B, that is 0.5 Tesla. This is the magnetic field provided over here. So the other end of the rod is in contact with a circular metallic ring. So here the dotted part is indicating that metallic ring, as we can see here. We can encircle and darken it. So we can say that this dotted part are indicating the ring. Now as it is given that the end part of it is in contact, now we are given that a constant and uniform magnetic field 0.5 Tesla parallel to the axis exists everywhere. So B is given, that is 0.5 Tesla, and we have to find out that calculate the EMF developed between the center and the ring. So as per as that equation that we have for the ring, that is 1 by 2 B L square omega. So we have to just put all the values, that is 1 by 2, B is 0.5, L that is 1 square, and omega that is 400. So we can have about 100 volt is the answer. So EMF that would be 100 watt, and that is the answer that we have obtained. Now another similar but an important question, that is the question number 6.8. So now we will move to that example number 8. What is given there in example number 8? In example number 8, it is given that current in a circuit falls from 5 ampere to 0 ampere. So here we are given delta I, that is 5 ampere. So we are given as a whole we can say that I2 minus I1. We are initially provided I1 as 5 ampere and I2 as 0 ampere. So delta I that we are finding is 0 minus 5, that is minus 5 ampere. So here the changes is negative. Now we are given that all this happens in time period, that is delta t, that is 0.1 second. This all happens in 0.1 second. If an average EMF of 200 volt induced, so EMF is also given here, that EMF, here we can see that we are given and provided different quantities. So EMF is given, that is 200 volt, and we are asked to find out that the self inductance of the circuit. So we have to find out the self inductance of the given circuit, and that we can apply over here. For this, what equation that we can use? It is very easy that we can apply the equation E is equals to minus L delta I over delta T. Now we have to just put all the terms, that is minus L delta I is here minus 5 and delta T is 0.1. EMF is given 200. So L is equals to 200 upon 50, that is, here it is minus L into minus 50. So we will ultimately get the answer as a 4 Henry. So L, that is self inductance, is obtained here is 4 Henry. Next example, that is our example number 9. Now in this example number 9, what are the conditions that they have provided? First of all, it is given that a pair of adjacent coils has a mutual inductance of 1.5 Henry. So here they have given the mutual inductance between two coils. So if the current in one coil changes from 0 to 20 ampere in 0.5 second, what is the change of flux linked with the other coil? Now, as per as the question is concerned, we are given here two adjacent coil that we will consider in this way. This is coil 1, suppose. This is suppose coil 2. They are lying in such a manner, they are very adjacent to each other, and actually we consider it in this manner. So I have to draw the figure again, that we consider that they are lying in such way. Suppose this is coil 1 and here the adjacent the coil 2 is there. Now they are having their mutual inductance in between them. So if this is 1, this is 2, we consider that M12, that is mutual inductance, is generally written as M is given that is 1.5, and so we are given 5 Henry as a mutual inductance. If the current in one coil changes from 0 to 20 ampere, so we consider that delta I is I2 minus I1, and here I1 is 0, and I2 is given as 20. So we have I2 minus I1 term as our question. Second thing, as they have given, that is time period. So here the time period, that is delta T, is given, that is 0.5 second. So all the terms that we are given, we can have the equation of flux linkage with it. Now we can apply the equation as E is equals to minus delta phi by delta T, that can be compared with minus L delta I upon delta T. Here minus sign will cancel each other. At the same, we can have the equation in the term, that is delta phi upon delta T is equals to L delta I upon delta T. We can simply cancel out the delta t terms as well, and we can have therefore delta phi is equals to L delta I. Now L, that is given 1.5, and delta I, that is given, that is 20 minus 0, that is 20. So 1.5 into 20, that will be 30 Weber. So the change in the flux, that would be a 30 Weber that we have obtained in this question. So this is your example number 9. Now from this we will move to the next example, that is example number 10. In this example number 10, they have given us the well-known example of a jet plane is traveling west at a speed of 1800 km per hour. So here we are provided a speed that is 1800 km per hour. So if we want to convert it into meter per second, it is very simple that 1800 kilometer is there, kilometer के मीटर होते हैं 1000, so it will be 1000 meter, and 1 hour has a second, that is 3600. So when we simplify this, we obtain, that is a 0 can cancel out, here 36 and 18 is there, so we can have that in 18 twos are 36, so we can have, that is 18 upon 36. Here this will be in a multiplication, so this is 1000 divided by 2, that will be 500 meters per second. So here the velocity is obtained, that is 500 meter per second. Then it is given that what is the voltage difference developed between the ends of the wings 25 meter long. So here we are given length, that is 25 meter long. If the Earth's magnetic field at the location has a magnitude of 5 into 10 raised to minus 4 and the deep angle is 30 degree, so that the magnetic field is given, that B is given as 5 into 10 raised to minus 4 Tesla, and angle of deep is also given, that is 30 degree. So as all the conditions are given here, we can have the condition that what is the voltage difference developed between the ends of the wings. So we have to ultimately find out the voltage difference that will develop between two ends. Now here we can consider this example as, if we simply think about it, that a jet plane is traveling west at the speed of 1800 km per hour. So the plane is traveling like this, we can consider it is traveling in this manner. We can have the direction of wings in the manner, it will be like this, like this. So now this is the plane heading towards the west. Now we are given different things, that L is given, this is the L, that is the difference or the distance between two wings, and the magnetic field has given the value, that is 5 into 10 raised to minus 4 Tesla. As we can see that it makes an angle 30 degree with that original magnetic field. So here we can calculate that B vertical, as it is moving in upward direction, so it is at very much height, and obviously it continuously change its position, so that B vertical can be given by B sine theta, as we think that if we consider it makes an angle of 30 degree with that angle of dip, so it will be 5 into 10 raised to minus 4 into sine 30, that sine 30 would be 1 half. So if we put all this value over here, we get the vertical component as 2.5 into 10 raised to minus 4 Tesla. So this is the magnetic field that we will calculate over here. Now we have to find out the EMF. That EMF is given by B, here vertical, B L V. So we will just apply the equation. B vertical is there, that is 2.5 into 10 raised to minus 4. Length of the wings are given, that is 25 meter long, and then the speed that we are applying, that is speed that we have obtained ultimately, that is 500 meter per second. So if we solve this, we get about tentatively 3.125 voltage. So this much voltage develop around the condition of E, and this will be the answer of the question number 10.